Today in the workshop, we'll be building a bench power supply using an old computer ATX power supply. You'll learn how the different types of ATX power supplies are wired up and how we can hook one up to create a versatile and powerful workbench power supply of our own. We'll even add in a power meter to measure voltage and current. We're getting all juiced up today, so welcome to the workshop. Hello and welcome to the workshop. Today we're going to build a simple but useful project, a bench power supply. Now here in the DroneBot workshop I have a number of different power supplies that I use when I'm working with microcontrollers or with electronics. You can see one of them here on my workbench. This is a DC supply, 0 to 30 volts. It's got 4 different preset outputs that I can set. So I can set 4 different voltages and it'll display the amount of current that's being drawn as well. This works up to about 5 amperes. I've also got a bench power supply permanently built into this workbench here. You've probably seen this before, a 5 volt and a 12 volt power supply that are mounted behind the workbench. I use that for a lot of my power needs. As well, I've got a whole box of these. I'm sure you probably do. These little wall warts. I've got USB supplies, 9 volt supplies, 12 volt supplies. And there are also USB supplies on my power bar. This little thing that rests my tablet also has 3 USB supplies in it. So I've got no lack of power supplies, and yet I've got a project coming up, a new and exciting project that you're going to be seeing a lot of very soon. And in order to build this project, I need a power supply. And I don't want to use my bench power supply, even though it's quite capable of satisfying the requirements, because A, I want to dedicate the power supply just to this project, and B, I might be moving the project into another room occasionally, and I can't take my bench power supply with me because it's built into my workbench. So I decided to put together another power supply, and I'm going to use this. Now, a lot of you are already familiar with these, I'm sure, if you've ever opened up a desktop computer. This is a computer power supply, or to be more accurate, an ATX type power supply. And this is one of the most common type of power supplies you will find in a computer. I got this power supply out of a very old computer, out of an old Windows XP computer that's time has come and gone, but whose power supply is still perfectly functional. I'm going to use this to build a workbench power supply that I can use for my project. I'm going to show you how to do that as well. Now, it's a very simple project because obviously they've already constructed the power supply for you, but I'm going to show you that it's not just a matter of connecting up the 5 volt and 12 volt lines to a couple of binding posts. There's a little bit of wiring involved. I'm also going to get rid of a lot of the wires on this power supply, so I'll be opening it up and showing you what's inside. But if you might ask, well, why don't you just go out and buy a power supply for your project? Well, power supplies aren't the most inexpensive things in the world, and you'll find that bench power supplies can get pretty expensive, whereas these, even if you have to buy them brand new, are about $40–50, and you can often just salvage one out of an old computer like I did. Now, what I want to show you about this supply is what's on the label here, and perhaps you'll see why I'm so interested in using it. Just let me focus this in for you. There you go. Now take a look at some of those specs over there. Now that's pretty impressive current it has on the 3.35 and 12 volt lines. And it's for that reason that I want to use this power supply. It's very powerful, it's very well regulated, and as long as you do this correctly, it's very safe. So what I'm going to show you is how these power supplies work. I'm going to show you the insides of this supply, some of the other parts we're going to need to put this project together, and then of course we're going to build it and test it out. So let's get going. Now here are some of the parts I'm going to be using for our project. Of course I have the ATX power supply itself. Now I wasn't able to get a connector to mate with the 20-pin Molex connector on the power supply, so because of that, I'm going to be using this terminal strip. I'm going to be cutting the leads on my power supply and putting wires onto the terminal strip. So I've got the terminal strip there. I've also got a number of these lugs over here that I'm going to put on the wires. I thought it would neaten it up a little bit to do it that way. I've got, of course, the binding posts that you're going to need for the project. I've got 6 of them. 3 of them are black, and then I've got 3 other colors. I'm only going to concern myself with the positive voltages, with the 3.3, the 5 volts, and the 12 volt outputs. I'm not going to worry myself about the 2 negative voltages on the supply, but of course you can wire those ones out as well. Now, I've got a power resistor over here. You're going to need a power resistor because you need to keep a load across the 5 volt line in order for the power supply to function correctly. And this style of power resistor I like quite a bit because it's actually, first of all, a 50 watt resistor, so it's can handle a lot of current, so it'll dissipate the power it's going to consume with no problem. It's also mounted in this package, which has a heat sink and can be bolted down, and that's going to be kind of nice because it is going to dissipate a little bit of heat. This is an 8 ohm resistor. It's actually meant to be a speaker load, but it'll work for this. You can also use this style of resistor if you wish, and something around 10 ohms is usually what they suggest you use. I've got a power switch down over here. Now this switch is going to be used actually as the power on-off switch. I've got a couple of LEDs and dropping resistors here. The LEDs are going to be a power on LED and a standby LED. And I've also got, and this is optional, but I thought they'd be nice to include, I've got 3 fuse holders and a number of fuses, and I'm going to fuse the output lines as well, just as an added measure of protection, although the power supply does have a shutdown mechanism if it does draw too much current. Now up at the back over here, I've got a few extra parts that aren't really part of the project, but I'll show them to you anyway. This is a volt ammeter. And I'm going to use this along with these binding posts to mount onto the same panel as the power supply output. And what I want to use that for is just to be able to patch one of these lines in and monitor how much current it's actually consuming. So it's not a permanent connection onto any one of the lines, but it's just a separate thing. So you don't need to worry yourself too much about that if you don't want to add something. But if you do want to add something like that, I'll show you how that works as well. So now that we've seen the parts that we're going to be using, let's take a closer look at the ATX power supply itself. Now here's my ATX power supply. This is a Series 1 version of the power supply, so it has a 20-pin power connector on it, as opposed to the Series 2, which have 24-pin. But they all look pretty much alike. They're obviously metal boxes. There's a output for a fan over here. Here's the actual power switch. There's a selector switch on it over here to allow you to select your line voltage. So I've got mine set to 115 volts, but if I was in Europe, I would flip that over to 230 volts. Here's the input for the power cord itself. Now, on this side we've got the connectors for the supply, and they're grouped into a couple of sets. Now this is the main connector. As I said, I've got the Type 1, so mine is a 20-pin connector. If you've got the Type 2, you'll have a 24-pin connector, and I'll show you how both of those can be hooked up. Now there's another connector over here that has just 4 pins on it, and this is just 12 volts. It was originally meant to power the fan and the computer power supply. This is the fan that goes on the CPU heatsink itself. And these are the connectors that are normally used to connect the peripherals up, things like hard disks and you know, DVD drives, etc., etc. You can connect with these. Now I'm going to get rid of these cables entirely, but I'm going to save them because they're useful for other projects. When you're expanding in a computer, these are useful to hook up extra power to things. I'm going to keep the lines over here, but as I said earlier, I'm going to cut them because I wasn't able to get a Molex connector to mate with this, so I'm going to have to wire to a terminal strip. I do want the extra 12-volt lines over here, you're going to find a lot of these lines are duplicates, and the reason is they just want to be able to carry all of that current. So rather than putting the current into one wire, they put it into multiple wires, and I'm going to keep that arrangement myself. So there you go, a typical ATX power supply. So let's take a closer look at the ATX power supply. ATX is an abbreviation for Advanced Technology Extended. This was a standard created by Intel in the mid-1990s for motherboards, but it also applies to the cases and power supplies that contain those motherboards. Since 1995, the ATX standard has become very common. In fact, it's likely the most common type of power supply that you'll find for desktop computers. Over the years, there have been several variations on the ATX power supply. The ATX power supply is a high current switching power supply. It supplies both logic voltages at 3.3 and 5 volts and motor voltages at 12 volts for a standard desktop computer. The ATX power supply is a sealed unit with an internal cooling fan. There are two versions of the ATX power supply. Version 1 can be identified with its 20-pin motherboard connector. Version 2 has a 24-pin motherboard connector. Here are the pinouts for the 20-pin and 24-pin power connectors on the version 1 and version 2 ATX power supplies. You'll notice that a lot of the wires are repeated in several different connections. The function of the wire can be identified by its color. The black wires are ground. The orange wires are positive 3.3 volts. The red wires are positive 5 volts. The yellow wires are positive 12 volts. On the version 1 supply, the white wire supplied negative 5 volts. This is not included on the version 2 supply. The blue wire is for negative 12 volts. The green wire is the PS on signal. When this signal is sent to ground, it will turn the power supply on. The gray wire is the power good signal. It will go to 5 volts when the power supply is working correctly. The purple wire is the standby wire. The standby is at 5 volts as soon as the power supply is turned on using its master switch. The standby wire can supply up to 2.5 amperes of current. There are other power connections from the ATX power supply as well for all the different peripherals in the computer. Some manufacturers use specialized connectors here as well. The ATX power supply has an AC input voltage selector to allow you to use it anywhere in the world. The rear switch on the ATX power supply does not turn the device completely on. It puts it into standby mode. To turn on the power supply, you need to use the PS on or green wire on the motherboard connection and bring it to ground. Many ATX power supplies require a load on the 5-volt output to function. This can be simulated with a resistor. Not all ATX power supplies have this requirement. Now I've opened up my ATX supply both to give you a look at what's inside and also to show you a couple of things that I'm going to be doing. I'm going to be taking some of these wires out. Now before we get started, I want to point something out. There's a couple of capacitors on this side over here. These capacitors can retain a charge for several hours or even several days after the supply has been unplugged. And they're on the high voltage side of the switching supply, so be very careful around those. They could still have a charge on them. Now, my power supply has, of course, a lot of connectors on it for peripherals, and I don't really want these wires anymore. What I'm going to do is I'm going to remove them down here. You can see the wires are grouped, and these are basically the output connections, the grounds and the voltage outputs and a couple of control outputs. And I don't want all of these wires, so I'm going to snip them down over here and kind of neaten everything up, and then just put everything back together. This all just fastens in with 4 screws. It's quite easy to get apart and get back into. Now, I will tell you something. There are a lot of people who have built these supplies, and what they've done is they've drilled some holes in the side here, and they've mounted their binding posts on there, and it's made a quite nice little arrangement, a little box that you don't have anything external to. And while that does look nice, if you're going to do it, be very, very careful. You don't want to get anywhere near any of the high voltage stuff over here. You don't want to interfere with any of the cooling that's so important to this power supply. So personally, I wouldn't recommend building it that way unless you really know what you're doing. If you are going to be soldering in here, make doubly sure that you don't have any soldered pieces that have fallen onto the circuit board. Give it a good shake afterwards. If anything else, you're probably going to want to open this box up just to blow out the dust and everything that's probably accumulated. This was pretty dusty when I first opened it up. But be very careful again around the high voltage area, and the only modifications I'm suggesting you do are removing a couple of these wires. None of the modifications of drilling into the side of the chassis or anything are going to be entertained here today. So with that said, let's get on with our project. So I thought that it would be a good idea to test out my power supply. After all, it came from an old computer that's been sitting unused for many years. Now, I've got it hooked up right now just sort of loosely on the workbench. What I've done is I've put my dropping resistor across a couple of the 5-volt lines, the 5-volt and the ground, and I've put a jumper on over here. This is from the power on signal, the green wire, to the ground, and that has turned on the power supply. And as you can see on my meters, I've got one meter monitoring the 5 volts and one monitoring a 12 volt, and as you can see, they're very, very good. Now, the one that's monitoring the 12 volt can actually be moved and can be used to probe further voltages. So I'll go to an orange wire, and that should be the 3.3. I'm getting 3.46, 3.47, so that's pretty good. There's a couple of wires down over here. This gray wire over here is the power good wire. It's at 5 volts. And the purple wire over here is a standby. It's also at 5 volts. Now, what I want you to observe is I'm going to remove the link I have from the power on to ground temporarily. So I've taken off my link, and I don't know, you can hear the fan has gone down. Now you'll see on my meters I've got 0 volts on the one that's monitoring 5 volts. And indeed, if I go back to the 12 volts, there's nothing over here. But if I go to this purple one, the standby line, I still have 5 volts. And what that shows is that you've always got 5 volts on the standby as long as the power supply has been turned on using the switch on the back of the power supply. Now let's ground the power on signal again. And you can probably hear my fan come back on. And now, again, standby still has voltage. But now the power good signal, which is the gray line, also has voltage. And these are the 2 lines we're going to use for the 2 LEDs in the front panel, by the way. Now my resistor doesn't seem to be getting very warm. It builds up a little bit of heat, but not very much. And I like the package that it's in. It's going to dissipate the heat quite nicely. You may not need the resistor, but many of these ATX power supplies required the resistor in order to start up correctly. If you find you don't need it, by all means just omit it from your design. But as you can see, my ATX power supply seems to be working properly. And so now that I've determined that, I can go ahead and build my project. So let's take a look at how we're going to hook up our ATX power supply to use as a bench supply. Now, as you'll recall, the motherboard connectors for both version 1 and version 2 have all the signals we need for the power supply, and that those signals are grouped into color-coded wires. I'm just going to show those color-coded wires on the hookup diagram, and I'm not going to show the wires for the two negative supply voltages because I'm not using them. So I've got the black, which is the ground, the orange, which is 3.3 volts, the red, which is 5 volts, the yellow, which is 12 volts, the green wire, which is the power supply on line. This needs to be grounded to turn the power supply on. The gray line, which is the power good signal. This will come to 5 volts when the power supply is operating correctly. And the purple line, which is the standby line. This will go to 5 volts as soon as the power supply has been switched on. I'm also going to need some additional components. An SPST switch. This is going to be my power on-off switch. A power resistor to use as a load across the 5 volts. I'm using an 8 ohm 50 watt resistor, but you could also use a 10 ohm 10 watt resistor or something similar. 2 LEDs, any color you like. One of them will be the standby light, the other one will be the power good LED. You'll also need some dropping resistors for those LEDs. I used 330 ohms, but any value from 220 to 470 would work just fine. I used 3 fuse holders. Now these are actually optional, but I decided they were a good safety option. You'll also need binding posts for your voltage outputs. I'm using 3 for the 3.3, 5 volt, and 12 volt output. As well, you'll need at least 1 binding post for ground. I'm actually using 3 ground posts, 1 for each output voltage. Now we'll begin by connecting our ground to the ground connection. Make sure to leave a lot of space with the ground connection because you're going to be making several connections to ground here. Next, we'll connect our supply voltages to the fuses, the 3.3 volt, the 5 volt, and the 12 volt. We'll connect the other side of those fuses to their respective binding posts. Next, we connect the PSO signal to one side of our SPST switch. The other side of our switch will be connected to ground. Next, we'll take the gray power good signal and connect it to the anode of the power LED. We'll take the purple standby signal and connect it to the anode of the standby LED. We'll connect the cathodes of both LEDs to one side of the dropping resistor and the other side of that resistor to ground. Finally, we'll connect our load across the 5 volt line between 5 volts and ground. And this completes the wiring of our bench power supply. So here we have my modified power supply. As you can see, there are substantially fewer wires coming out of it than we had before. What I did was I eliminated a lot of the excess wires I just wasn't going to use, and I just clipped them right at the circuit board. For all the major supply voltages, I took 3 wires. These are 18 gauge wires, so by putting 3 together, it can handle substantially more current. And for each one of them, I put a lug on the end, I crimped it, then I soldered it, and then I put some heat shrink tubing on it, so it's pretty secure. Now this is the yellow one, so this will be the positive 12 volts. And we've got an orange one down here. Again, I took 3 of them. That's for the positive 3.3 volts. Now, I've got 3 of the red ones over here for my positive 5. And I also took an additional red and a black, and I soldered my resistor across them. So this is the power resistor I'm using for a load. Now, if your supply doesn't require a load, you of course won't need to do that. But I just took an additional red and black wire to do it. Then on top of that, the ground wires. There are a lot of ground connections, so I actually took 6 of them and again soldered them up in groups of 3 to a lug and then put some heat shrink tubing over them. So I've got 2 ground connections here. And then I've got the 3 individual connections that I'm going to need. This is the power on, the signal that when you send to ground will send power off to it. This is the standby signal. This has 5 volts on it as soon as the power is on, and this is the power good signal. It goes to 5 volts when the supply is operating correctly. So I've got everything prepared to mount on a base and then hook up to my front panel, and I'll show you those bits next. Now here's the base I'm going to be using for my power supply project. It's a very simple wooden base. I'm sure you can come up with something fancier than this, but it does the purpose. Now I've got my terminal strip down over here, so this of course is where I'm going to be connecting all of the wires from the power supply and all of the wires from the front panel. And the front panel I will show you in a moment, and that of course will have all my fuses and my binding posts for the voltage outputs. Now the front panel itself is going to mount with these 3 angle brackets, and I don't know if you can see that, but I've actually bent the brackets back a little bit just so I could sort of tilt the front panel back a little bit. Now these brackets here are all to mount the power supply. What I've done with the power supply, if you take a look at the ATX Supply, there are 2 screws over here, 2 taps for it, then another tap over here and 1 down here. So in order to mount it, what I decided to do was I built a bracket at the back over here, and I put a couple of brackets on over here, and the supply just sits down in here, and these holes line up with the screws at the back, so I can just put a couple of screws in there to hold it. This just clamps it at the side, and on this side over here I used a taller bracket, and I've got this little self-tapping sheet metal screw. Now I was very careful to look in the supply and found there was nothing directly behind here, and so by putting this screw in over here I can actually secure the supply down to the base over here. So I'll put that in right now, and then between that and the screws that hold it at the back, it's pretty secure, at least for the purposes I'm going to give it. And then I've got my power resistor. If you'll notice on the base here, there's a couple of holes down here that have been drilled, and so I'm going to mount the power resistor on there, then connect all the wire to the terminal strips, and then that part of the project is complete. Then all I really need to show you next is the front panel and how I'm going to mount it over here and wire it to the terminal strip. So let's take a look at that now. Now this is the front panel that I've come up with for my power supply. Now again, I've made it out of a piece of wood. I know it's rather crude looking, but it does serve the purposes. As you can see, I've got the outputs for the 3.3, the 5 volt, and the 12 volt. I've got the fuses mounted right above them. And I've got 3 ground connections, 1 for each voltage. These are all, of course, just connected together. I've also got my switch over here, which can put it into standby or power on mode. And I've got the 2 LEDs. I used a blue LED for my standby LED and a red LED for my power good. Now you'll also see that I added a power meter, a volt amp meter, that I put into the case, and I've got an input to it over here that's the positive input, and then the output that you'll be measuring the load from. And I'll talk about that in a little while, but of course this is an optional thing. It's not part of the actual project, and you don't need to include a meter if you don't want to. Now if you look on the back over here, one thing I did, I don't know if you can see this very well, is for the ground I actually used a piece of 14 gauge solid wire, and I used that as my ground. I put it across all 3 ground connections and then ran it out to the terminal strips. It's very solid, so it actually does serve to support the base to a small degree as well, and that way all of the ground connections I needed from everything I could just solder to. As you'll see again, I used 3 wires for the 3.3, 5, and 12 volts, and in order to go to the fuses, because those wires go to one side of the fuse holder, the other side of the fuse holder goes to the terminal strips, and I just used a short piece of 16 gauge wire. I didn't think I'd drop too much voltage or suffer too much current loss with a 1/2 inch piece of 16 gauge wire over here. Otherwise, these are the connections to my LEDs. I probably can drop some epoxy or hot glue in the back here, but they seem to fit pretty nicely. You'll note that I used heat shrink tubing over everything. The dropping resistors that are associated with each LED are actually underneath the heat shrink tubing, and then it goes to a common ground, which is on the back of this switch over here. And this is the power on switch, so it's got one lead going to the green wire and the other side of the switch going to ground. And I've got the gray and the purple wires. Now the purple wire is the standby wire, so that gives you 5 volts as soon as the power supply is on. And I'm actually using that to power my little meter over here, so that's what the other connection to the meter is. And the rest of these connections are for the meter, and again I'll explain that at the end of the video. But as you can see, it's basically a very simple panel, and it'll go on the front over here. I've got my angle brackets, and so this will slip down just on the front, and I'll wire the connections up to the terminal strip over here, and then that will pretty well complete the power supply project, and we can test it. So I'm going to wire that up right now, and then we'll give this a test. Alright, now here's my supply. I've placed the front panel on, and I've fastened it down, and I've connected all the wires, so it's actually just ready to test. Now I've got the switch on the back off. When I turn it on, the supply will go into standby mode, and you can see the standby LED. You can also see the power came on to my power meter, and that's because I'm powering it from the standby power supply. And again, the power meter is just an optional thing, but it seems to be working right now. Now if I go and measure the voltage, however, I won't have any voltage right now on any of my outputs, and that's of course because the supply is in standby mode. So let's place it in the power mode, and the power good light comes on over here. You may be able to hear a little bit of fan noise, although it's a pretty quiet power supply. And now here's my 3.3 volts. It's actually measuring a little hot at about 3.5 volts. And my 5 volts is just about bang on. And my 12 volts at 12.17 volts is pretty good as well. And so there you have it, a bench power supply constructed from a ATX type power supply, and this actually will be a very handy unit, not only for the project I'm planning to use it for, but for my workbench in general. Now of course I'm going to tell you a little bit about this power meter in case you want to add one of those onto your project, so let's discuss that right now. Now there's actually a story behind the meter I'm adding to my power supply. It didn't actually turn out to be the way I'd originally intended, but in the long run that was a good thing, and I'll explain what I mean by that. I went over to my electronics store with the idea that I was going to buy 3 of these little meters and put one onto each supply voltage, and that way I could measure the current draw of all 3 of my output voltages. However, when I got to the store, they only had 1 in stock. So I bought it and took it home. In retrospect, I'd wished I'd also bought a 3-way switch, so I could just switch between the 3 voltages instead of the arrangement I have over here with the input connector, but it is what it is. However, when I got the meter home, I started looking online to figure out how to hook it up, and found out that the shunt, the thing that you use to measure the current, is actually on the negative side of the meter and not the positive side. And that creates a bit of a problem. It would have created a real problem if I'd had 3 of them, because then I would have had 3 output voltages whose grounds were at slightly different potentials. It's still a valuable unit, but in a way I'm glad I only got 1 of them. Now as you can see, I've mounted it here on the panel, and it can measure voltage and it can measure current. And this is my input connector, and what I do is I connect the output voltage, one of these 3, to the input connector, and then I connect my load across here, and I can measure the voltage as well as the current that the load is drawing. Now another thing about this meter, when I went over to the store, it was advertised as being one that could measure 0 to 100 volts at up to 50 amperes. Well, looking at the spec sheets I've seen online, yes, it can do 0 to 100 volts, but the maximum may be as low as 10 amperes. So again, it may not be the perfect meter for the project. Nonetheless, let me show you how I wired it up, and then we'll take a look at a quick test of the meter just to watch it in action. Now the power meter module that I'm using is a model DSN VC288, and on the back of it you will find two sets of connectors. One set has two very thick wires, a black wire and a red wire. This goes across the current shunt. It does not go across the power supply. If you do this, you'll literally short out your power supply. There's also another connector with three wires, a black wire, a red wire, and a yellow wire. Now here's how we hook this up. The current shunt is hooked on the ground side, so you take the black wire and connect it to the input ground. You then take the thick red wire and connect it to the output ground. The input voltage and output voltage are connected together. Next, you'll take the yellow wire from the other connector and connect it to the input voltage. This is the sensing wire, and it measures that voltage. The other two wires on the connector are a small black and red wire. These are the power supply for the module. There is two ways that you can wire this. If you wish, you can connect the red wire to your input voltage and use this to power the module. However, your input voltage needs to be between 4.5 and 30 volts for this to work. In my case, I'm also measuring 3.3 volts, so this won't work for me. So I'm taking my red wire and connecting it to a 5-volt input, which in my case is the standby voltage that comes from the power supply. The black wire is then connected to ground. And this completes the wiring of the DSN VC288 module. Now let's take a look at it in action. So let's give this power meter a test. Now I've got the supply on in standby mode, and of course the meter is already powered up because it's using the standby voltage. So what I've got over here is a power resistor, and I've attached it just to a couple of cables so I can plug it in. I'm going to plug this in as my output load. I'm going to turn on the power. Now, of course, I've got nothing connected to the meter right now, so there's nothing for it to read. So what you need to do is take a lead and connect it to the input, and then go to whatever voltage it is you want to pass through the meter. So we'll start with our 3.3 volts, and it's reading 3.48 volts. And you can see the current that we're pulling right now, 0.17 amperes is what this is reading, and that's because of the load over here. If I take off my load, you'll notice that my voltage goes up a bit because there's no load on there, and of course I've got no current that I'm pulling, so let's pull it back in. It seems to sample every second or so, so I notice a slight delay when I make changes over here. Now let's go over to the 5-volt side. And there we are, we're reading 5 volts, 0.25 amps is what we're drawing. And we can now go over to our 12-volt side. And it's measuring 12 volts at 0.63 amps. So as you can see, it's a relatively useful little meter. It could be good for monitoring one specific output voltage. Just remember that this ground is not anymore at the same potential as these grounds, because you've got the little shunt in here that it's using to measure the current. And so that could be an issue if you want to connect this ground to the common ground of another power supply. But if you're just measuring something on its own, this is a pretty cool little meter to use. And so there you have it, our power supply and its meter. Alright, I want to make one additional note to those of you who might be concerned about opening up an ATX power supply. You might be concerned about the high voltages that are in there, and it's a very valid concern. Or you might have purchased a new ATX power supply to use as a workbench supply, and you don't want to violate its warranty by cutting a bunch of wires. There's a number of solutions for that. One of the solutions is that you can buy a kit or a pre-made board that is already set up to convert an ATX type power supply into a workbench supply. And you can get these things. They have a connector on them. It's usually for the type 2 ATX supply with a 24-pin connector. You simply plug the connector onto the board. The board has the binding posts and the switches and the LEDs, essentially the same stuff that we've wired up over here. It's already on the circuit board for you. You can get these circuit boards pre-made. You can also get them as kits. SparkFun, for example, has one as a kit, and it will allow you to do exactly what we've done today. Convert an ATX power supply into a useful workbench supply without even needing to open up the box. So you might want to look into that if you're not willing to jump into your supply and start snipping things around. At any rate, that brings us to the end of this video. I hope that you enjoyed it, and as always, you will find an article that accompanies this with the schematic diagram that we've used on the dronebotworkshop.com website, so you'll find a link below the video to that. While you're on the website, if you haven't already, could you please subscribe to my newsletter? It's my way of keeping in touch with you and letting you know what's going on in the workshop, and there are a lot of changes happening in the workshop in the next couple of weeks, and I'll be keeping in touch with you via the newsletter to let you know about those. The newsletter is free. There's no advertising in it. Just send me your email address and you're on the list. And speaking about being on the list, if you're not a subscriber to the YouTube channel, please do me a favor and click the subscribe button. I would really appreciate it, and that way you would know when I create new videos here in the workshop. So until next time, please take care of yourselves, and I hope to see you very soon again here in the workshop. Goodbye for now.